guys have the lesson 2 practice quiz that you guys got last week? It's the handout that had the lesson quiz 1 on one side and 2 on the other. And I'll show you what it looks like. This, remember? Three questions that I want you guys to spend about 6 minutes thinking about, talking about. Good. Let's think and talk about them together. The first one, we have 2 polygons. And the question asks us to determine whether the polygons are similar. From what we can see, are they?
No.
Who says no?
There.
Who says yes? Who says I'm not sure yet? But given enough time, I may be able to come to a more decisive conclusion.
It's just that.
From the people who say no, why do you say no?
I don't think the said no.
You said no.
I said no, sad.
Anyone have an answer? Well, are the sides proportional? How do we write it out? How do we write the proportions of the sides?
B, C to F, G, B, A to F, E, A, D to E, H, and G, H to C.
The small one to the big one.
They're not similar because one is a square and the other one's a...
Right? So, if I were to write the proportions for the sides, it would look like they're similar, because I would take BC to FG.
Like that.
I would take CD to GH, and so on, right? And one might be deceived that they're similar, but why aren't they? Alejandro said it.
They're different
Polygon.
polygons.
They're different polygons, but how do you know?
Because one has a 90-degree angle.
Oh, one has a 70-degree angle.
Okay? So in order for 2 polygons to be similar, they need their corresponding angles to be congruent. And this one doesn't. You can see that right away. So, this is 70, right? This will be 110. And this is 90 all the way around, right? So these 2 polygons cannot be congruent. How about number 2? Number 2 is something you can do pretty quickly. The model of a sailboat's dimensions, a model sailboat compared to an actual sailboat's dimensions, is 1 to 30. Okay?
So it's 1 inch over 30 inches for an actual.
Yeah. If the length of a model is 10 inches, then what's the length of the actual sailboat? Oh, it actually goes from inches to feet. So it's 1 inch to 30 feet. All right, so if we know that the model is 10 inches, then what's the sailboat going to be?
300 feet.
Right?
Yeah.
Does everyone see how they did that?
Yes.
Oh,
What's the proportional? Or what's the proportion?
130.
130,
130 equals 10x.
10x.
X.
I cross multiply. Cool.
I did that myself.
That's all right. I showed my steps. We're both okay. Ha. Number 3. Suppose that, we want to know if this statement is sometimes true, always true, or never true. 2 equilateral triangles are similar. Okay? Think about it, and I want to call somebody to come up and take a crack at showing if that is sometimes true, always true, or never true.
Always.
Oh, can I explain why?
Hold on. I'm going to let the calculator decide. 11. It's an honor.
It's an honor.
Come on, we'll help you. It's easy.
Special. Four, 8, 12.
Here, right here. We're done with this. We have the statement that two equilateral triangles are similar. What should we do first?
Draw the equilateral triangles.
Draw two equal.
That sounds like a plan. Draw two equilateral triangles. They don't have to be to scale. Okay, that's fine. What can we do to show that these are equilateral triangles?
Put on the equal congruent sign.
We can put the congruent little hashtags. What else can we do?
Name
The angle measures.
We can
Or
well, if it's an equilateral triangle, what's the angle measures?
60.
60.
So we can name the lengths, right? Something to say. So name the side lengths for the first triangle. Give me anything.
ABC.
But not the vertices, the sides, the lengths. Give him the letter. Okay, name the vertices. And the second. Oh no, they're gonna have different vertices. Okay. All right. Now. No. Now that we have vertices, we can call them by name. What do you want to say the length of AB is?
2.
It could be 2. It could be X.
It could be 200.
It could be 200. Let's call it X. Then it could be any of those. Okay? Just an X. Okay. Everyone can see that, right?
Yeah.
Right in the back? Okay. So if that side's X, what are the other sides?
X.
Yeah? You guys agree?
Yes.
It's an equilateral triangle, so all of its sides are X.
Yeah.
All right, how about the second one? Let's do the same. It's different. It's a different. Good. All right, we have two equilateral triangles. One with sides X all the way around. One with sides Y all the way around. Now, how can you show that these two are similar?
I know X and Y, right?
No. I mean, if we did, we could see that they're similar. But how, with using just X and Y, how have we shown already in the lessons that we've done? Write the ratios for their corresponding sides, just like we did here.
X to Y. 3 times.
Yeah. X
Wait, we'll add X to Y to Y to Y.
Yeah, write them as a fraction.
Three times?
Uh-huh. And is X to Y equal to X of Y? And is that equal to X of Y? Yes.
Yeah.
So you write your equal signs. Thank you. You can sit down. So take a look at what we did. We have two equilateral triangles with unknown sides, but we know that they're the same all the way around, right?
Yes.
And when we write these proportions, it turns out to be true. X to Y is equal to X of Y, which is equal to X of Y, right? Is that true for two triangles never, sometimes, or always?
Always.
Always, right? These can be any number, and the proportions are going to be the same. Thus, equilateral triangles are similar is a statement that is always true. Good. All right. With that, we're going to start 7.3 with an exploration, and I need help passing on stuff. I'll try to bring the geoboards back. Oh, I thought you were raising your hand. Thank you for your help. Thank you. for this exploration, you guys can use the back of the handout to draw your triangles. I need to pass that project.
What's your what?
Oh, thank you. So you might notice too that unlike other explorations that we've done, this exploration asks for you to write your name at the top because, hey, everyone,
People.
I'd like to collect these from you at the end of class. So, yes,
We're supposed to do
today they're actually going to get done. Alright? Yes.
I know that one's not gonna. Look, this was mine.
Here you go. Okay, in this exercise we're drawing two triangles. They are not going to be congruent, but they're going to have two equal angles. Right? Okay? There you go. So, with the ruler end of this projector, draw two unequal bases. And I'll do this in the front.
I'll take it.